far beyond the known boundaries of the inner solar system, in that region where sunlight has diminished to a mere residual glow that barely pierces the primordial dust, an event has occurred that fits into no conventional astronomical category. There, where most interstellar objects traverse the deep void with absolute indifference to our technology, 3I Atlas has just exhibited behavior that completely contradicts scientific expectations. Internal motion, detected by multiple independent systems, recorded with precision and confirmed with no margin for instrumental error. It was neither superficial detachment nor vibrations caused by external forces. It was a real, coherent displacement within the object's core, as if an internal structure had changed state or position. The first measurements from the James Webb Space Telescope revealed a brightness change sufficient in itself to classify the event as anomalous. An emerald green flash emerging from the interior, followed by an abrupt transition to a deep violet tone. This chromatic leap displayed neither a coherent thermal gradient nor an ionization curve compatible with volatile materials. It was a sudden, almost instantaneous alteration suggesting the presence of internal layers capable of modulating light through a still unknown mechanism. The temporal sequence of these changes also coincided with a thermal drop of approximately 100 degrees Celsius, recorded in an interval of just a few seconds. No natural body can absorb such an amount of energy inward without displaying external fractures or structural collapse. Yet the object remained intact, as if its surface were designed to redistribute thermal imbalance efficiently. In parallel, Hubble and Solar Orbiter confirmed the appearance of transient geometric patterns on the object's superficial layer. The most stable form detected was a perfect hexagon, visible for only an instant, yet long enough to identify its sharp outline and internal coherence. This geometry then gave way to a series of luminous spirals that appeared to expand outward, modulated by an internal oscillation of consistently repeating frequency. The presence of regular geometries on a body subjected to gravitational stresses, variable radiation, and micro-impacts from the interstellar medium should be impossible, yet the patterns cannot be dismissed as artifacts. 3 distinct instruments recorded them simultaneously. The second relevant anomaly appeared as a rhythmic, albeit brief, electromagnetic pulse. Its periodicity, initially irregular, began to stabilize as the object advanced into a region where Jupiter's magnetic field generates intense fluctuations. The pulse was neither background noise nor a solar interaction effect. It exhibited a stable profile and intensity proportional to the recorded thermal drop. Initial measurements indicate that the pulse originated from the deep layers of the core rather than the surface, suggesting the presence of a cavity or internal structure capable of generating or amplifying electromagnetic signals in response to external stimuli. No comet, even one of metallic composition, has ever shown such a direct relationship between magnetic stimulus and internal reorganization. The third element of this phenomenon was even more disconcerting. Orbital dynamics data revealed a minute deviation of approximately 0.0002 degrees, recorded immediately after the electromagnetic pulse. Although the magnitude of the change is almost imperceptible on astronomical scales, its temporal synchronization with the luminous and thermal phenomena points to an internal mechanism capable of producing a dynamic response. It was not a random deviation. It was not the product of solar wind or nearby gravitational perturbations. It was a precise, coherent modification coupled to events within the core. For an object that should behave as a rigid or semi-rigid body, this ability to adjust its trajectory is entirely unexpected. When optical, thermal, magnetic, and dynamic data were integrated into the analysis matrix, an even more troubling pattern emerged. Each event, the chromatic transition, the thermal drop, the electromagnetic pulse, the superficial geometries, and the orbital deviation, manifested in mutually compatible time intervals, forming a regulated sequence. It was neither chaos nor random reactivity to a changing environment. It was a kind of internal choreography, a gradual process advancing in stages, as if each phenomenon served as the trigger for the next. Projecting the sequence onto the object's historical records reveals an upward trend in pulse intensity and luminous pattern complexity, which may indicate progressive activation. The more data intersected, the clearer it became that the object's core is not solid, but possesses a hollow or semi-hollow structure with internal sections capable of shifting, rotating, or reorganizing. James Webb's interferometry sensors provide faint but repeated indications of central density variations, as if internal compartments alter their distribution under certain levels of solar radiation. The absence of visible sublimation reinforces this hypothesis. No jets, no fragments, no volatile traces. As if the object were constructed to withstand extreme temperatures without losing integrity. As if its internal structure were designed, or naturally predisposed, to maintain a precise balance between rigidity and adaptability. And from the latest measurements emerges another notable correlation. The light reflected by the object displays polarization patterns reminiscent of superconducting or crystalline materials subjected to intense magnetic fields. Definitive confirmation is still lacking, but spectral signatures suggest an internal interaction that cannot be explained solely by ordinary minerals. The repetition of electromagnetic pulses in the presence of Jovian field lines indicates that the object reacts to magnetic configurations with extremely high sensitivity, completely incompatible with natural bodies composed of random mixtures of metals, silicates, and ice. As the integration of this entire complex of phenomena progressed, the hypothesis that quietly, almost involuntarily, began to impose itself was that the object behaves neither like a comet nor like an interstellar asteroid. Instead, it appears to manifest signs of a cyclically functioning internal system, as if its structure had remained dormant for an incalculable length of time and is now entering a phase requiring reorganization, response, or awakening in the face of stimuli from the inner solar system. The recorded variations in geometric patterns, the magnetic pulse, the thermal drop, and the orbital shift compose a sequence sufficiently coherent to regard what is observed not as accident, but as the manifestation of a complex internal process, a process that continues to intensify as the object approaches regions where the energetic environment becomes more variable. And as these patterns become more frequent, an inevitable question arises. If the object is showing ever more signs of internal organization, how far will this process go when it advances into regions of denser solar radiation or interacts with more intense magnetic fields? The trend suggests that we have not yet seen the peak of activity and that what has been recorded so far may be merely the initial phase of a phenomenon whose deeper nature we are only beginning to outline with scientific caution. As we continued to integrate core data, it became evident that the behavior of 3I Atlas could not be interpreted as a fortuitous reaction to the magnetic environment of the inner solar system, but as a multi-level, structured process in which physical layers appear to respond with distinct patterns depending on stimulus intensity. In particular, variations in Jupiter's magnetic field showed an unexpected correlation with the electromagnetic pulses recorded in the hours following the orbital change. The object did not react only while passing through the most distorted portion of the field. It continued to exhibit sustained activity even as the gas giant's influence began to wane, as if the initial interaction had activated a mechanism now operating autonomously, independent of immediate external changes. Vector analysis of light polarization revealed that the oscillations followed neither a purely radial nor tangential pattern. Instead, they were distributed in a kind of ordered superposition, with defined peaks appearing at regular intervals along the estimated rotation axis. Such a distribution is not typical of irregular surfaces or materials fracturing under thermal stress. On the contrary, it recalls crystalline surfaces or structures with internal layers capable of refracting light in predictable patterns. The pattern's consistency led the team to develop a preliminary model, a segmented internal structure that responds to energetic variations by redistributing mass or density, generating pulses that filter to the surface as visible modulations. While we examined these models, a new James Webb capture showed that the deep violet tone had stabilized. Yet within that stability, sporadic flashes appeared on wavelengths associated with energy transition processes. These flashes were not random. They repeated at the same cadence as the detected magnetic pulses, suggesting that the core is undergoing energy exchange between its internal layers. Closer analysis of the temporal curve of these flashes revealed that each occurred slightly before the full electromagnetic pulse, as if representing a preparatory internal phase prior to releasing the main signal. This reinforces the idea of a cascading process inside the object, in which different layers activate sequentially. The surface texture also began to show new variations. The initially isolated hexagonal patterns began to intertwine with the spirals detected hours earlier. This intersection of geometries implies that we are not dealing with randomly superimposed phenomena, but with structures attempting to organize according to an internal order that we cannot yet fully model. The possibility that the core possesses a fractal geometry or a system of cavities aligned according to unknown principles remains a working hypothesis, but the data point toward a complex internal architecture, possibly based on materials that reorganize their structure in response to magnetic and thermal stimuli. One of the aspects that most struck the team was the central density measurements obtained by interferometry. Although the error margin is high due to distance, the observed fluctuations suggest that the core is not entirely solid. On the contrary, it exhibits regions where density briefly decreases before returning to its usual value. This variation could indicate internal mass displacement, as if compartments exist that expand or contract in a controlled manner. The hypothesis of a partially hollow structure, already considered from Block 1, gains strength when observing these movements, as it explains how the object can absorb thermal shocks without fragmenting and generate small orbital modifications without matter ejection. We then examined data from solar orbiters' high-frequency radiation sensors. These showed that the core's electromagnetic pulses do not propagate uniformly in all directions, but exhibit slight directionality, oriented toward regions of intensified solar influence. This directionality suggests that the object may orient its internal pulses according to the structure of the solar electromagnetic field, although we do not yet understand whether this results from a natural resonance mechanism or a more complex process that adjusts its response based on the energetic environment. What is remarkable is the constancy of this orientation, which does not change abruptly despite solar variations, as if the object calculates an internal equilibrium that keeps the response stable. As analyses progressed, the team compared 3I Atlas's internal signals with known superconductivity patterns. Although the data are not conclusive, certain surface light signatures show a troubling similarity to the behavior of superconducting materials subjected to extreme temperature changes. The abrupt thermal drop recorded in Block 1 fits perfectly with such a transition, an internal reorganization that drastically reduces temperature while the system reconfigures its molecular or crystalline structure. If this hypothesis is confirmed, we may be facing an unknown type of material capable of operating under extreme conditions without losing structural coherence. To this was added a new discovery during ultraviolet spectra integration. On a lateral section of the core, a faint signature was detected that could correspond to modulated radiation, an extremely weak emission type that appears to repeat at regular intervals. Although the signal could be due to solar-wind interactions, its regularity and synchronization with the core's magnetic pulses suggest it belongs to the same internal process. This possible modulated emission raises more questions than answers, especially given its nearly constant periodicity. No purely natural cometary phenomenon produces signals of such stable coherence. As we examined these signals, the preliminary three-dimensional density map began to show an elongated central structure surrounded by layers of alternating densities. This configuration could explain how light passing through the object generates hexagonal and spiral patterns, as the different layers would act as filters or modulators of reflected light, allowing internal behaviors to become visible on the surface. Most intriguing, however, is that these layers do not appear chaotically arranged. On the contrary, they exhibit faint regularity, as if their organization followed still uncomprehended geometric principles. The question of whether we are facing a natural phenomenon or a more complex mechanism began to recur among several team members. Although scientific caution demands avoiding premature assertions, it is evident that the recorded patterns defy conventional expectations. The hypothesis of an internal structure with sequential behavior does not automatically imply artificiality, but it forces us to reconsider the range of physical processes capable of producing such coherent internal reorganizations. While analyses continued, a new chromatic variation began to manifest on the surface, an intermediate hue between deep violet and a silvery blue tone. This change appeared correlated with a new, milder, but equally rapid thermal drop. Additionally, surface density showed a slight, almost imperceptible redistribution that could indicate the object's outer layers adjusting to accommodate internal processes. This adaptation suggests the phenomenon is not concluded, but is in an intermediate phase, possibly advancing toward further reorganization or activation. Finally, the dynamic models revised during this phase show that, if the object maintains this trend, we may observe new orbital variations in upcoming observation windows. The magnitude will be small, almost imperceptible, yet the accumulation of these variations could provide crucial clues about the internal mechanism generating such adjustments. With the chromatic, thermal, and density variations consolidating, the next analysis phase required an even closer combination of optical data, electromagnetic records, and dynamic measurements. There were patterns that, in isolation, could pass for statistical curiosities. But once integrated, they began to form a broader conceptual structure, as if scattered pieces were finally fitting into a common scheme. The behavior of 3I Atlas exhibited a degree of internal coherence too high to continue interpreting it solely under conventional parameters of cometary behavior, and the sum of phenomena indicated that the process identified in previous blocks continued with disconcerting stability. The three-dimensional density map, which until then offered only an approximate representation of internal cavities, began to gain resolution with the incorporation of the latest interferometric readings. In the new version, fluctuations showed redistribution not only vertically but also horizontally, as if certain internal regions were moving in groups while maintaining constant geometric relationships among themselves. This regularity suggests the existence of compartments with defined boundaries, capable of expanding or contracting while preserving their relative proportions. In short, the variations did not occur in isolation but followed a pattern that, to our knowledge, has never been observed in natural bodies without fragmentation. While reviewing this distribution, thermal records showed a second abrupt, albeit attenuated, temperature drop. This coincided with an internal reorganization that the three-dimensional model interpreted as the simultaneous displacement of several compartments. The temporal correlation between the two phenomena suggests an internal mechanism that immediately redistributes energy, as if the object possessed a thermal damping system capable of absorbing heat and transferring it to deeper regions without causing fractures. The fact that this occurs without mass loss or sublimation points to extraordinarily resistant materials, perhaps even capable of maintaining superconducting states under variable solar radiation. In parallel, the electromagnetic measurement team observed that the detected pulses were acquiring a more defined periodicity. Initially, peaks were irregular and difficult to separate from background noise. Now, however, they appeared grouped in ensembles following a particular sequence. This sequence recalled charge-discharge cycles in energy systems, as if the object's core were oscillating between high and low activity states in a structured cadence. The transition between these states appeared accompanied by a slight redistribution of central density, reinforcing the idea of a mechanism that adjusts its internal configuration according to these electromagnetic cycles. Another significant advance came from spectral interpretation. Surface variations no longer manifested merely as tonal shifts. They now began to appear as reorganizations of reflectance, indicative of changes in the microscopic structure of the surface material. This reorganization seemed directly or indirectly linked to the geometric patterns detected in preceding hours, particularly the spirals that appeared and disappeared on the surface. Overlaying these observations gave rise to a preliminary hypothesis. These geometries could be visual representations of internal waves propagating through highly structured materials, anisotropic crystals, or three-dimensional networks capable of changing configuration under specific stimuli. However, what most captured attention during this analysis phase were the local magnetic field measurements. The detected variations did not originate exclusively from the object's environment. Rather, part of the field appeared modulated from within. This modulation was not arbitrary but followed a pattern coinciding with the electromagnetic pulses and thermal reorganizations. On several occasions, measurements showed symmetry suggesting that the object not only responds to the external magnetic field, but generates its own internal field capable of actively interacting with the environment. Although this idea still requires more rigorous validation, solar orbiter signals point to an internal structure with magnetic properties far exceeding those of common minerals. Integrating the complete dataset, luminous, thermal, magnetic, spectral, and dynamic, produced a provisional yet coherent model of the object's behavior. This model suggests that 3I Atlas may be undergoing a sequential internal reorganization process activated by external stimuli, such as Jupiter's magnetic field, solar radiation, or environmental thermal variability. The process appears to present differentiated phases: energy absorption, structural reorganization, electromagnetic emission, and dynamic adjustment. Each phase is linked to visible surface patterns such as hexagons, luminous spirals, and abrupt chromatic shifts. From this model began to emerge a question previously relegated to the background due to its conceptual complexity. Could this object be configured to respond automatically to specific energetic environments, as if it had been designed or naturally formed to activate under certain conditions? This question does not seek to insinuate artificiality without direct evidence, yet it is inevitable to consider the possibility that we are facing phenomena we have not yet properly categorized. Hollow structures, geometric patterns, and coordinated electromagnetic responses constitute an unusually complex set of properties for a traditional interstellar body. While the team discussed these possibilities, a new luminous sequence began to manifest in the received records. Characterized by an internal glow that gradually intensified before collapsing into a uniform flash, it initially seemed an isolated phenomenon, but its repetition at defined intervals indicated it was an additional component of the object's internal cycle. This behavior is particularly noteworthy because it is accompanied by a surface reorganization that briefly forms patches of hexagonal symmetry before fading. These geometries could represent the surface adjusting to internal changes, an interpretation consistent with the detected density variations. During this sequence, the orbital deviation experienced a minimal but measurable adjustment. Although the magnitude of the change remained extremely small, its synchronization with the most intense phase of the luminous pulse suggests that the internal mechanism redistributes not only energy but also mass. This dynamic adjustment could indicate that the object possesses the capacity to modify its trajectory through an internal reorganization process, a phenomenon never previously observed in natural bodies and which, if confirmed, would pose a direct challenge to classical orbital dynamics doctrines. Throughout this phase, the patterns emerging on the surface gained increasing clarity. Hexagons became sharper, spirals acquired greater depth, and previously uniform areas revealed new structures with irregular outlines. This evolution suggests that the internal process is gaining complexity and that superficial layers are reacting more markedly to profound changes. The surface acts as a visible map of internal processes, and the geometric structures could represent tension points or nodes where energetic reorganization reaches its maximum. These observations led the team to formulate a more advanced hypothesis: that the object possesses an internal system composed of multiple interactive layers that collectively respond to the energetic environment. Akin to a bicrystalline mechanism or a system of resonant cavities, such a structure would explain the combination of observed phenomena, internal reorganizations, electromagnetic pulses, chromatic variations, and orbital deviations. The observed behavior could be the superficial interface of profound internal processes whose logic we have not yet fully deciphered, but which appear governed by coherent structural principles. The growing body of data suggests that 3I Atlas may be progressing toward an even more complex phase of internal reorganization. Recent variations indicate sustained intensification with no signs of immediate stabilization. On the contrary, the object appears to have entered a state in which every interaction with the environment, thermal, luminous, or magnetic, increases internal activity and leads to new surface configurations. This process raises fundamental questions about the object's nature, origin, and purpose, if that term can be applied scientifically, especially since the latest data suggest an increase in structural coherence that could indicate the process is still in an intermediate stage, and the most significant manifestations are yet to come. With this growing structural complexity and the expansion of luminous patterns, the object seems to stand on the threshold of a new internal state. The interplay between light, density, magnetism, and motion suggests an intensely organized system that may be approaching a critical phase. And although we cannot yet fully comprehend the direction of this process, it is evident that what we are observing is not a superficial phenomenon, but a profound evolution continuing to unfold at its own pace, a pace that intensifies as the object advances toward regions of greater energetic variability within the solar system. At this point, the totality of accumulated evidence no longer permits regarding the behavior of 3I Atlas as a mere cosmic accident. The ordered sequence of observed phenomena, from luminous reorganization to internal density changes through magnetic variations and orbital deviations, constitutes a self-sustaining process that appears to increase in complexity as it progresses. The internal organization suggests that further developmental stages remain, especially as the object nears regions where physical conditions could trigger deeper levels of activity. And thus, while models project a gradual intensification of these phenomena, the central question is no longer whether the object will continue to evolve, but how far it will go, and what revelations the coming phases of this process may bring. A process which, through its internal behavior, reveals a nature far more complex than ever imagined.